Let's begin by looking at the origins of groundwater. As rain falls on the surface, a small amount of it seeps into the earth, passing through porous layers of rock. Water can also migrate downward more quickly through cracks, crevices, and sinkholes. The downward movement continues until the water is trapped by layers of clay or non-permeable dense rock, which causes the water to saturate and collect and create underground aquifers. These may range in size from microscopic to large caverns. Often, people think aquifers are extremely large continuous underground pools that cover many square miles. This is true of some aquifers, such as the Edwards Aquifer beneath San Antonio. In these situations, the entire aquifer's water level is quickly recharged by rainfall anywhere across the entire area, so everyone shares equally in the sum total of replenished groundwater. But this is not the situation in the Trinity aquifer system. The Trinity system comprises aquifers of different permeabilities that have been created by a complicated rock structure with numerous layers and variations of composition and density, and therefore variations in permeability. Permeability is the measure of the rock's ability to allow water to flow through it. So rainfall is not shared equally by all residents and landowners of Kendall County. The total volume of water resources in the Trinity Aquifer cannot be easily measured, because, as you can see here, our groundwater is dispersed across areas that have varying rock densities and permeabilities. This situation makes it very difficult to even compare water resources for wells that are in close proximity. One landowner may have plenty of draw from his well, while a neighbor's well may be in decline because they are drawing from different aquifers at different depths. Or consider this: you may have drilled your well to the same depth as your neighbor's wells on both sides of your property. But in a complicated geological environment like ours, you and one of your neighbors may be drawing from the same type aquifer, while your neighbor to the other side may be drawing water from an interval with different aquifer permeability characteristics. That's why it is difficult to know whether your neighbor's well usage is affecting your water supply or not. Still, another complicating issue has to do with the aquifer's recharge rate. In this location, the rock is more porous and the underlying aquifer recharges faster, compared to the rate at which water seeps downward through denser rock in this location. This disparity makes it difficult to anticipate when individual sections of the Trinity Aquifer will recharge, and even more difficult to predict the availability of a given area of Kendall County to support growing demand. Another issue that complicates matters is the fact that groundwater can be a moving target as it migrates at different rates between aquifers, depending on the size of the connecting pathway and the porosity of the rock. Now you should have a better perspective on how our ability to measure and manage our groundwater in Kendall County is dictated by a very complicated geological structure. You now understand that the groundwater available to residents and landowners across the county can vary greatly, depending on the portion of the Trinity Aquifer from which their wells draw, and the speed at which different portions of the aquifer recharge. It's evident that when demand or pumping exceeds the recharge rate of an aquifer, the net result is a loss of available water for all residents and landowners who draw from that same aquifer. Some areas with lower permeability or tighter rock may see more dramatic effects of depletion than other areas of the county.